Hey everyone, welcome back to my channel, the Travlin Prof. Today we are going to be discussing logical principles. This is part one of several in a series, understanding types of basic statements. Now you may be asking right away, what does logic have to do with an intercultural studies YouTube channel? And that's a great question, and we'll get back to that at the very end of this video. But as we begin, let's dive right in with a very simple question. What is logic? If you Google a definition of logic, you will find that logic is reasoning conducted according to strict principles of validity. And this definition includes several key parts that we're going to discuss right now. They're on this slide. The first is reasoning. Some might use the word thought as a synonym of reasoning, but they are actually just a little bit different here because reasoning is intended to refer to a series of thoughts that is used to arrive at a good conclusion. The second thing that we come up with in our definition here is strict principles. Logic and the study of logic are governed by a set of rules. In order to think properly and arrive at conclusions about a set of facts, these rules must be followed exactly. Otherwise, we risk faulty conclusions, which may or may not have drastic consequences depending on the seriousness of our question. And the third and last part of our definition that we're going to talk about is validity, that last word. So when we abide by these set rules in our reasoning, we can be sure that we will ultimately discover if a statement is true or false. That is the goal of logic, to discover whether a statement is true or false. So a word of caution, make sure that your facts are right before you begin logical reasoning. Logic is reasoning conducted according to strict principles of validity. And logic is built on a set of blocks. Actually, it's just one block, but it is used many times to come up with the final picture. The most basic element in logic is a statement. Statements can be very simple in their most basic form, and they can include a basic declaration of reality from the speaker's point of view. Statements follow two general rules, and by default have one very important characteristic that we're going to discuss right now. First, statements must be free of context. When we analyze statements for the purposes of determining their validity, we must avoid sentences that require context for their truth to be determined. For example, the sentence that is on the screen, "He is the best teacher in the world." This sentence is not verifiable because it requires that you understand my train of thought in the specific context. I could be talking about my friend who taught me how to fish, who, in my mind, to my perspective, from my experience in the world, is the absolute best fishing teacher in the world. But you wouldn't know that. Thus, that statement is not verifiable by anyone who has not had the exact same life circumstances that I have had. Second, statements are assumed to be intentional declarations of fact. If we wish to evaluate the validity of someone's statement, we must first acknowledge that the person who is making this statement is, in fact, able to make a sound declaration that this is a fact. The example sentence, "It is raining." This is a verifiable statement as opposed to the first sentence because it is either true or false. And we recognize that if I go to the window and look outside and I see liquid precipitation falling from the sky, I can say and make a statement of fact, "It is raining." Now, last but not least, and truthfully, this is one of the most important parts of logic, statements are either true or false. If a statement is almost true or true 99.9% of the time, then it's not true. It's actually false. There is no middle ground in logic when it comes to statements. Without strictly implementing the standard of true and false, there is no arriving at a final logical conclusion. Now, in order to work with logic, we need to know how to write a sentence using logical notation. And there are a couple of guidelines. First, a statement as a whole will be represented by a capital letter. So our sentence that we've been using, it is raining, we can represent with just the plain old capital R. Also, connective words. Now, these are words like and, or, not. These connective words are not just written out when we make logical notation. They are represented by symbols. And, which is a conjunction, is represented by the ampersand. Or, which is a disjunction, is represented by a caret. Not, which is a word of denial, is represented by a dash. Example number 1. The most simple one that we can come up with, and we just talked about it. It is raining. That's our statement. So if we replace raining with an R, because an entire statement is represented with a single capital letter, our statement, it is raining, can be written R. Example number 2. It is raining and it is snowing. Once again, raining is expressed as capital R, and, which is a conjunction, is replaced by its appropriate symbol, the ampersand. Snowing is expressed as S. And when we combine these three elements together, our statement is now written R and S, which is a very simple way to understand the logical structure of it is raining and it is snowing. And our third example, it is raining or it is not snowing. Let our first sentence, it is raining, once again be replaced with the capital R, and our second sentence, it is not snowing, once again be replaced with the capital S. Now we have two other things to add into this statement and the logical notation for this statement. First, we are using or, which is our disjunction symbol, the caret. And since the statement claims that it is not snowing, which is our denial word, we will use the dash in front of S. Therefore, our statement can be written R caret dash S, which would be read R or not S. Now, when we talk about logic, we ultimately want to find out what is truth. There are only two possibilities. But when they are combined, things can get a lot more complicated very, very quickly. So we talked about three additional kinds of statements: conjunction, disjunction, and denial. Conjunction statements are true if all components joined by and are true. So, it is raining and it is snowing. If it is both raining and snowing, then the whole statement is true. Now, if even one of those is false, then the whole statement is false. Disjunction statements are true, a little bit different than conjunction, because if a disjunctional statement has one part that is true, then the whole statement is now considered true. It is raining or it is snowing. If I say that, and you walk up to the window, look outside, and you see that there is snow falling from the sky, you assume that I've told the truth. It is a valid statement logically because only one part is true. Now, it's not raining, that part's false, but it is snowing, that part's true. Therefore, disjunction statements are true if only one component is true. The third kind of statement, denial statements, are true when the opposite is false. Now, let's look at these ideas in a chart. We call these charts truth tables, and they're a very easy way to quickly express how logic builds into understanding. So our simple statement, once again, we're not going to change it just for simplicity's sake. It is raining. We replace the whole statement with a capital letter R. And remember, statements must be either true or false. Therefore, the R has two possibilities. Either it is true or it is false. It's a very simple truth table. But what happens when we add some elements to it? In this, we have a conjunction. It is raining and it is snowing. Raining, we'll let it be represented by R. Snowing, represented by S. And our conjunction symbol is represented by the ampersand. Now, in order to know the number of possible outcomes of a situation when we have more than one part to a statement, we need to get the power of 2 that is equivalent to the number of statements. For example, we have 2 statements. It is raining, it is snowing, RS. Therefore, we square the number 2, arriving at 4 possible outcomes. If we had 3 parts to our statement, it is raining and it is snowing and it is foggy, we would then take the cubed power of 2, which would be 8 possibilities. But for right now, we only have 2 statements, so we are left with only 4 possibilities. Now, because a statement can only be true or false, that means we have to try to arrange our table in such a way where all possibilities are demonstrated. So if the first statement is true and the second statement is true, then we look at our rule for conjunction statements. All parts of the statement must be true in order for the whole statement to be considered true, and we see that R and S is indeed true. Now continue on to the next row. If R is false and S is true, then R and S must be false, because the first part of the statement is false. Move on. If R is true and S is false, then R and S must still be false because one part is not true. If both R and S are false, then obviously R and S is false because neither is true. So for a statement with a conjunction, all parts of the statement must be true or the statement is false, and you can see that expressed in this table. Now for a statement with a disjunction, that is the word or, it is raining or it is snowing. What is our rule for a statement with disjunction? If even one part of the statement is true, then the whole statement is valid. Again, we have the same number of possible outcomes, 4, because we have 2 statements. But this table is a little bit different. Notice that the first line in the conclusion column, the true is in parentheses. And really that's because if both parts of an disjunctional statement are true, we wouldn't normally use a disjunction, we would use a conjunction. Think about it like this. If I go to the window and I say it is raining or it is snowing, and you go to the window and you see that both are true, you're probably going to say, yeah, it's raining and it's snowing. You're not going to repeat it's raining or it's snowing. That would leave some doubt as to whether or not it's doing both. Moving on, if R is false and S is true, then R or S is actually true. Because the second one is true, one part is true, therefore the whole statement is true. If R is true and S is false, the same deal, R or S is true. But if both are false, R and S are false, then the statement that we have, R or S, is also false because neither is true. And lastly, we have a statement of denial. It is not raining. Now, if our normal statement, it is raining, is represented by R, then it is not raining must be represented by -R. And if R as a statement can only be true or false, then the denial statement has to be the opposite. So if the statement R is true, then not R must be false. If the statement R is false, then the statement not R must be true. So if I go to the window, I look outside, and I say, it is raining, when actually it's not raining, then it is not raining is true, and it is raining is false. And now we get to our question. Why does logic matter in cultural studies? And that's a great question. First, remember that logic is the means of arriving at truth using a set of strict guidelines as you reason your way to a conclusion. Now, every culture is different, and some approach the question of logic very differently. Consequently, as you go around the world and as you explore different cultures, different worldviews will inevitably clash, challenging your perspective on the world. Now, taken at face value, these differences are not bad. They are not evil. As a matter of fact, if we were all exactly the same, how boring would this world be, right? To truly understand the differences between your culture and a foreign culture, however, you must be able to express your thoughts logically. Otherwise, you will never be able to reach a valid conclusion about anything you see. And so, logic and intercultural studies are related very closely. Logical thought frames our investigations into foreign cultures and allows us to make valid statements about them. But intercultural studies supplies the most relevant and accurate facts so that our logical statements can be formed correctly. These two aspects, logic and intercultural studies, are very intimately intertwined. You cannot do good logical reasoning about a foreign culture if you do not know how to do intercultural studies. And you cannot do intercultural studies and arrive at valid conclusions if you cannot think logically. So this summarizes the relationship between logical thought and intercultural studies. And so that is the end of part 1 of logical principles for intercultural studies. We'll see you again soon, but until then, get curious and start digging.